Evaluating absolute value expressions. So the first question is, what is absolute value? Absolute value you can think of as the distance from 0 on a number line. So here's 0, here's -7, here's +3. This is 3 units from 0. 3 units to the right, we call it +3. This is 7 units from 0. Okay, so how far it is from 0. Not whether it's to the left or to the right, but how far. So we say this as the absolute value of -7, and the symbol we use is a pair of absolute value bars. So they're vertical bars, vertical lines. We say the absolute value of -7 is 7. The absolute value of 3 is 3. Okay. Basically, really what we do is we just take whatever's inside the absolute value bars and make it positive. The absolute value function actually has to think. If a is greater than 0, or greater than or equal to 0, so the absolute value of a is just a if a is greater than or equal to 0. And if not, then it's -a. So if a is less than 0, in other words, if a is negative, we take the negative of that, and the negative of a negative is a positive. So if you were to program an absolute value function, unlike a lot of the functions that we've looked at till now, like f of x is x squared plus 7x plus 12, where you substitute the value of x, you would square it, multiply it by 7, add that on, and then add 12. An absolute value function actually has to look at the value and say, if it's positive, I'm just going to leave it alone. I'm just going to return to you the value of a. However, if a is a negative value, then I will return to you the negative of this negative value, which will be a positive value. Okay, what else do we have? Well, we could put numbers in order by absolute value. And again, that would just be making the ones that have an absolute value positive and placing them in order. And you can see an example of that at the top of page 361. And we can work with expressions. Well, what if I have the absolute value of 3 minus the absolute value of, that's not very clean, let's clean this up, minus the absolute value of -7. Well, we treat absolute values like brackets, so you evaluate this. The absolute value of 3 is 3, minus the absolute value of -7 is +7, and 3 minus 7 is -4. So despite the fact that there are absolute values in the expression, that doesn't mean our answer will be a positive. It simply means that we must make whatever's in here positive before we do anything to it. Let's try another one. Let's say we have 3 times the absolute value of -5 plus 2. Whoops, I was going to make that an absolute value. Plus 2 times the absolute value of 12 minus 20. Okay, this will become 3 times 5, the absolute value of -5 is 5, plus 2 times the absolute value, 12 minus 20 is -8. So this is equal to 15 plus 2. You know, you got to make these look like absolute value bars, not like ones or something. So 2 times 8, which gives us 15 plus 16, or 31. Okay, how about an expression like this? We have the absolute value, and the bars pair up, so this bar pairing up with this bar, of 3 times -4 quantity squared plus 5 times -7 plus the absolute value of -3. So all we do is we treat everything like brackets. So it's the absolute value of 3. -4 squared is +16. Plus 5 times -7. Well, let's just call that -35. So minus 35 plus 3, and then absolute value So we get the absolute value of 48 minus 35 plus 3. 48 minus 35 is 13, plus 3, the absolute value of 16, which is just 16. So in the end, our absolute value signs on either end didn't have any effect on the final answer since it was already positive, but you know, they're still there, and you have to work out everything in between them. Again, like a set of brackets, then at the very end you look and you just say, all right, whatever is in here, whatever number is left in between the absolute value signs will become a positive number. Let's say I have 2 points, point A at 7, -3, and point B at -5, -3. And we could graph these. Oops, not up there. So let's say here's point A at 7, -3, and here's point B at -5, -3. And we say, well, how far apart are those 2 points? Since they're on the same horizontal line, then all we're interested in is the difference of their x values. So I could say, well, the difference between the x values would be -5 minus 7. Now that's going to yield a negative. We want a distance. So to make a distance, we're just going to call it the absolute value of -5 minus 7, the absolute value of the difference between the x coordinates, which is the absolute value of -12, which is +12. And we're talking distance, so we're interested in a positive number. If we had done this the other way, we would again just have taken the difference between. So again, I'm going to say absolute value of 7 minus -5, which is the absolute value of +12, or 12. Using the absolute value signs, or symbol, assures us that no matter what order we do the subtraction in 7 minus -5, or -5 minus 7, no matter what order we take the difference between the x coordinates, by taking the absolute value, we will end up with a positive distance. And how far apart things are, generally we're interested in a positive distance. All right, let's look at an application of absolute values. So let's say that the Warriors have the football on the opponent's 35-yard line, and what we're interested in is, over a series of plays, how far does the ball travel in total? So in other words, you know, a one passing play 35 yards would score a touchdown, it would cover 35 yards. But let's see what happens if we have a number of plays. So on the first play, let's say there's a 10-yard pass to the 25-yard line. Let's keep track over here. So we'll go 35 minus 25 equals 10. It's traveled a distance of 10 yards. On the next play, they go to hand off in the backfield, get pushed back, and end up on the 28-yard line. So we started on the 25, we ended up on the 28, which is a loss of 3 yards, but really we're interested in how far the ball traveled. So in order to get the total distance traveled, we're going to start taking absolute values. So first play was 10 yards. The absolute value here is 3 yards. So we've traveled a total of 13 yards. The ball has traveled 10 yards this way, 3 yards that way, which is 13 yards. Okay, next play, we're going to have a passing play. We'll go from the 28-yard line and end up on the 15-yard line. So we started at 28, ended up at 15. The absolute value of 13, which is 13. On the play after that, they're called for holding, and so we go from the 15-yard line, we're penalized, and move back to the 25-yard line. So the absolute value of 15 minus 25, because you know what I'm doing is our starting yard line is our first number and our finishing yard line is our second. We started at the 15, ended up here, which is a loss of 10 yards, but the ball traveled 10 yards. Okay, and that's what we're interested in this particular question, is the total distance the ball travels. Okay, we have a pass and run play, which takes us to the 5-yard line. So we started at the 25, ended up at the 5. Total distance, absolute value of 20 is 20. They're called for offside on the next play. End up back at the 10-yard line. So we started at the 5. Absolute value of -5. So loss of 5 yards, but the ball traveled 5 yards. And on the next play, run in for a touchdown. Started at 10, ended up at 0. The absolute value of 10 is 10. And what was the total yards covered by the ball in this series of plays? So we have 10, 13, 26, 36, 56, 61, 71 yards. So for traveling upfield, a total of 35 yards, but based on the different plays, the ball has covered a total of 71 yards through these various plays. And that's where absolute value comes in. And again, because I'm always going with the here's where we started and here's where we ended up. So 35 minus 25 is 10. We started on the 25 but ended up on the 28. This would be called by the commentators a loss of 3 yards, but we're interested in the fact that the ball has now traveled a total of 13 yards. 10 yards forwards and 3 yards back is still 13 yards. This applies the same. If you're driving your car backwards, you still want to be counting that towards the total mileage, so your odometer needs to move in a forwards direction. Key ideas for absolute value are on page 363, and you can look through the other examples. There's one on change in stock value, and again, we don't really care if it's going up. Well, certainly if we own it, we care if it's going up or down, but if we're interested in how the value is changing, just like here, we're interested in all of our changes being positive numbers. And so we need to take absolute values for that. We could do the same thing if we were talking, excuse me, about temperatures. Temperature changing from plus 10 degrees to minus 10 degrees is a 20-degree change. You could think of it as minus 20, but it's a change of 20 degrees. Just the same as in going from minus 10 to plus 5 would be a change of 15 degrees. And if we want to know the change, then we either have to work very carefully with the order we do subtraction in, or we don't care about the order we do the subtraction in. We just use one as the starting temperature, one as the ending, and then take the absolute value to ensure that we end up with a positive number. And that will cover for us evaluating absolute value expressions.